All right, good morning. Day 1 of Unit 9. Needless to say, your tests are not graded yet, so that probably won't happen till the weekend. So we'll get those on Monday, most likely. This is a shorter unit, and it's a 50-point test, and it is not an open note test, okay? It's a test over the unit circle. In some ways, what we do today is like all you'll need. It's not quite true. We'll add a few things as we go, but today is the big day for developing the unit circle, and then we'll tweak it, play with it, learn it better as we go. But today's a big day for learning the unit circle. So we'll start with some notes. You guys at home, we have a cutout activity, so you just kind of have to play along as we go. But let's start with notes, and then we'll get to the cutting and pasting stuff in a moment. All right, knowing the unit circle combines 2 or 3 things that in theory you already know, but we're not going to assume you know those things. We're going to rehash them and reteach them, and then we'll think that you know them. One of the things is the special right triangles. Some of you have mentioned things like this and wrongly tried to use them on the test occasionally. Whoops. Where we have a 30, 60, 90 right triangle. And there's a pattern that goes with the sides of a 30, 60, 90 right triangle. Does anybody remember what the pattern is? It's been a long time. Across from 30 is A. Jogging any memories? Across from 60 is A square root of 3. And the hypotenuse is 2A. And in geometry you had to memorize that, and you'd put a pattern on a triangle and use the pattern to find the missing sides. And we'll do that again in a moment. What was the other special right triangle? 45, 45, 90. That one's a little easier, I think, because these two sides have to be the same, right? If they're both across from 45, they're equal to each other. Do you remember what the hypotenuse of that triangle is in terms of A? A square root of 2. So you would put the pattern on a triangle, use the pattern to figure out the other sides. In fact, let's do that a couple times here. So there's our problem. 30, 60, 90 right triangle. And across from 30 is a 4. The best way to work these problems is to put the pattern on the triangle and then figure out what A is. So across from 30 is A. Across from 60 is A square root of 3. And the hypotenuse is 2A. So this is a relatively easy one because A is 4. So that makes it real easy to figure out what the other sides are. If A is 4, well, that means this side is 4 square root of 3. And the hypotenuse is 8. You remember doing that in geometry long ago? Okay, some hesitant nods. Let's try another one. with a 45, 45, 90 right triangle. That one should be relatively straightforward. So one of the sides is 7. Let's put the pattern on. We use the pattern to figure out that A is 7. So that means that side's 7, and the hypotenuse is 7 square root of 2. So special right triangles play a big role in the unit circle. Let's do 2 more of these. It'll be even more useful for what we're going to do today. I like to change up the orientation of the triangle because otherwise people start to think, oh, A is the side on the bottom and A squared root of 3 is the one on the side. Like, no, it goes with the angles. Let's say our hypotenuse is 1 for this triangle. So put the pattern on. Across from 30 is A. Across from 60 is A squared root of 3. Hypotenuse is 2A. So what's A equal to in this problem? 1/2. So this is a little bit trickier, not much trickier, but a little trickier to figure out what A is equal to. But if 2A is equal to 1, then A is 1/2. So one of our sides is 1/2, and one of our sides is 1/2 root 3, or we'll just say root 3 over 2. But the process was the same. Put the pattern on, match them up, figure out what A is. And again, we're headed toward the unit circle. All of this is triangles, so you may be wondering, how in the world does this apply to a circle? We'll get there. Let's do another one where the hypotenuse is 1. But this one's a 45, 45, 90. So A and A squared root of 2. This one's going to be even a little bit harder to figure out what A is. I mean, not that bad, but we'll have to do a little bit of work with square roots here. A is 1 over the square root of 2. But we don't like that. We want to fix that. So A is root 2 over 2. And I guess the good news is at the back end I don't have to do anything. If once I know what A is, I know my missing sides. They're both root 2 over 2. Okay, that's sort of the first chunk of information that we'll need to operate or to work with the unit circle. The next thing we're going to look at is this worksheet, and I'll give it to you in a minute, but you guys at home need to print out the packet so you can start working on this. Resume. So we'll take a few notes kind of at the top, right? Fill in the unit circle. You don't know how to do that yet. But what we do know is from the test we took yesterday is that sine of theta was, let's start with what we know for sure, that's SOHCAHTOA, O over H. But maybe more importantly, in terms of x's and y's and r's, do you remember what sine is in terms of x, y, and r? Who went with opposite? X or y? Y. Good. I hope you know this. You got tested on it yesterday. And r was the hypotenuse. And cosine was adjacent over hypotenuse, and that's x over r. Now, the reason this is called the unit circle, it'd almost be better if it was called the 1 unit circle. 1 unit, because r is equal to 1. So we look around that circle, that is nowhere labeled there, but when we say the unit circle, all of those radii are length 1. So let's head back up to sine and cosine. If r is equal to 1, then y is equal to sine theta, right? Sine theta is y over r, but if r is 1, then y is sine theta, and x is cosine theta. And so all those ordered pairs that you see around the outside of that unit circle, of course they're x comma y like normal, like a normal ordered pair is. But the x tells us the cosine of that angle, and y tells us the sine of that angle. So that's kind of the big deal of the unit circle, is the x and y coordinates are the same as the cosine and sine of that angle. And so if we know what that coordinate is right there, then we'll know the cosine and sine of the angle. In fact, we're going to fill those out. It's going to take us a while to do so because there's a lot of blanks, but the coordinate right there is going to be x comma y, but it's also cosine comma sine. And so that's kind of the big deal with the unit circle, is x goes with cosine, y goes with sine. Right, let's start with the unit circle. Let's do the easy stuff first. And let's label the degrees. So you see the degree markers in there. So 0 and 360, that's the easy ones. I'll label in the same order that I labeled all of them. Halfway around is 180. Half of that's 90. I'm not worried about the in-between stuff yet. And then down at the bottom, 270. Okay. There's 3 angles in there. One of them's right in the middle, so that one we should be able to figure out for sure. What angle is right in between 0 and 90? 45. In fact, let's go ahead and fill in all the 45s, all the right in the middles. So this one over here is right in between 90 and 180. So you can either average 90 and 180, or you could recognize that it's 45 more. So it's like you're counting by 45. So 45 plus 45 is 90. Plus 45 is 135. Plus 45 is 180. That's a good check. Unit circle has tons of self-check while you're working on it. 45 more, 225. 45 more, yeah, 270. 45 more, 315. 45 more, 360. So I feel pretty good about the 45s because I knew half of them already and they kind of checked out as we went. Now, you're either going to need to be really good at eyeballing, or you can think about what we did to start with special right triangles. And so I need an angle that's in between 0 and 45, a little bit closer to 45 than 0, and an angle that we just talked about a few minutes ago. So what do you think that angle is? 30. And in fact, if you sort of ignore the 45 markers, which is admittedly kind of tricky to do, just like ignore them and not see them, but if you can ignore them or cover them up, then all the other markers are 30 degrees apart. And so if you ignore the 45, we can count by 30 all the way around. So 30, 60, 90. 90's already there, but that's good that that checks out for us. 120, 150, 180, that's already there. Again, I'm just adding 30 for each 30-degree increment there. 210. Hop over the 45, ignore him for now. 240, 270, that's there, that's good. 300, 330, 360. Okay, that wasn't too bad. What do you think the next, we'll kind of work our way out here, what's the next blanks for? What do you think? Radians. A little bit harder, but 0 and 2 pi, that's the easy ones. Halfway around's pi. Halfway between 0 and pi is pi over 2. And for these fractions, you can use that line as the fraction bar. So rather than sitting pi over 2 on the blank, use the blank as the fraction bar and call it pi over 2. At 270, you might remember that that's 3 pi over 2. And that's sort of it for the easy ones. Now we got to do a little bit of thinking here. 30 degrees. Let's see, maybe just over here somewhere up at the top. 30 degrees. If we want to convert that, we're all experts at converting now because that was on the test yesterday. So what would I multiply by to convert? Pi over 180. So that's pi over 6. So 30 degrees is pi over 6. Now, I could go convert every single one of those. That would take forever. I don't want to do that. I want to do what we kind of just did when we counted by 30s. I ignored the 45s. I want to count by not 30, but pi over 6. So be careful. Don't write anything down because a lot of these are going to reduce. But if this is 1 pi over 6, then this is 2 pi over 6, also known as pi over 3. Yeah, you are. And again, I'm trying to teach this so that eventually, I should say it out front, you're going to have to know this whole thing, but you don't have to memorize the whole thing. Several years ago, somebody counted, I think they came up with 65 blanks on there. And like, we had to memorize 65 things? Like, no, you do have to memorize some of it, but you can figure out a lot of it. And so, yeah, if you want to memorize all 65 things, knock yourself out. I'm going to try to teach it where if you understand a few key things, then you can fill out the rest. So that's what we're doing now. If I know that 30 degrees is pi over 6, and even if I forget it, I know how to convert it. It's not a big deal. Now I'm going to count by pi over 6s. So 1 over 6, 2 over 6, 3 over 6, it's already there. 4 over 6, except don't write that down. What's 4 over 6 reduced to? 2 over 3. And then whenever I reduce, I pretend to lose count. So I'm going to go back here and say 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6. 6 over 6, okay, that's there, that's good. 7 over 6. 8 over 6. 8 over 6. That would be 4 over 3. That was 8 over 6. Or again, if you got to start over, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 6. That's okay. 10 over 6. 10 over 6. That would be 5 over 3. 5 pi over 3. Oh, I lost count again. 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5, 6, 7, 8, 9, 10, 11 over 6. I didn't really lose count. I just wanted to count again. Because that's how you do it. If you get stuck somewhere, like, oh, just go count over the 6s until you get there. And then one other over 6 would be 12 over 6, which is 2 pi. So it checks out. So we found all the the not 45s, but we only did one conversion. Like, we didn't sit there and write out however many, was that 8? We didn't write out 8 different of these times pi over 180 things. That'd take forever. We did one of them. And after you work with this enough, you'll just remember that the smallest angle is pi over 6, and then you can figure everything else out from there. All right, I still need to do the 45s. So maybe I'll do the 45 times pi over 180. Over 180. What's that reduced to? Probably something between 3 and 6. Pi over 4. And now, just like we counted every 45, I'm going to count every pi over 4. And just like we counted every pi over 6, there'll be some reducing to do along the way. So pi over 4. 2 pi over 4. Okay, that's right. 3 pi over 4. 4 pi over 4. Okay, yes. 5 pi over 4. 6 pi over 4, which is already there, that's fine. 7 pi over 4. 8 pi over 4 gets us back to 2 pi. So again, there's the angles in the unit circle. Do you have to know those? Yes. Do you have to memorize those? You got to know a little bit to get you started, but once you know a little bit, you can fill out the rest. All right. What I want you to do now is to get, you may not have 3 colors of highlighters, so you may need to share with friends, and I can share as well. So hopefully between you and your neighbors, you can rustle up 3 colors of highlighters. I also have 4 I can loan. Does anybody want 1 or 2? You want another one?
I don't have any, so
I got a blue and a yellow. Anybody on this side want a blue or yellow to complement what they've got? Again, I don't really expect you to have 4 highlighters or 3 highlighters, so share with those around you. Even if you got none, that's fine. I got 1 more yellow. Anybody? You got a yellow. Anybody else with a yellow? Want a yellow? Okay. It's okay, you're a soccer player. All right, here's what we're going to do. So watch carefully. We're going to highlight some things, and please don't highlight until I highlight, or else you're going to be messed up the rest of the unit. So pick a color. It doesn't matter. I'm going to use yellow, but it doesn't matter what color you use. And any denominator that has a 6 in it, I'm going to highlight with yellow. So any of these radii that have a denominator of 6, I'm going to highlight in yellow. Again, it doesn't matter which color you pick. It's more about pick one color. All the over 6s make that color. Again, you need to be very careful today. Several years ago, a student felt like they kept missing this one particular problem. I was like, yeah, I don't understand why you keep missing that. What's going on? I was like, let me see your original unit circle that we worked on. She had something labeled wrong on there. So she had memorized correctly, but she had memorized the wrong thing correctly. It was a bummer. All right, so that makes like a giant X in there. You know what? Before we go further, let's look at that. I sort of gave away the punchline. All of those are over 6s. What's the reference angle for all of those? 30. What's the reference angle in radians? Pi over 6. 30 is equal to pi over 6. So all of those reference angles are pi over 6. They're also all symmetrical. We'll worry about that in a minute. All right, pick another color. Doesn't matter which one. Pick a different color. Again, be friendly with your neighbors, borrow, share, whatever. And let's do all the over 4s one color. Again, carefully, because you can't erase highlighters. So make sure you're doing the over 4s. Same thing, a lot of symmetry going on. They're all over 4. They all have a reference angle of 45, or pi over 4. They could all sort of reflect onto each other. You could guess what we're going to do next, probably. Grab a third highlighter color. Again, check with your neighbor, share, borrow. And all the over 3s let's highlight. They're all the over 3s. Highlight all the ones that are over 3. And we could say the same things about the 3s that we did the 4s and the 6s. Lots of symmetry, reference angle, all pi over 3, or 60 degrees. They're all sort of didn't say this earlier, all the 60s are all my green ones, all the over 3s are the steep angle in each quadrant. That's a lot of how we'll work this problem. So maybe back up toward the top. Over 6 is always the shallow angle in a quadrant. Over 6 is always the shallow angle. And I guess if we really wanted to be fancy, we could make that match your picture. So whatever color you use, now you have to trade back maybe. Whatever color you use for the over 6, you could highlight shallow angle or pi over 6. That's always the shallow angle. So when it comes to graphing these, if it's something over 6, you know it's going to be a shallow angle, not the steep angle and not the middle angle. Anything over 4 is always the middle angle. So I'm going to get my over 4 color and highlight or underline or kind of make a point of that. And again, so anytime you get an angle that's something over 4, it's going to be right in the middle of whatever quadrant it lands in. And then the over 3 are always the steep angles. So whatever color you use for over 3. So anytime you have to graph anything over 3, you know it's going to be a steep angle in the quadrant. And we've already worked on landing them in the right quadrant, because that's when you think about, well, is it bigger than 1/2? Is it bigger than 1/2? Is it bigger than 3 pi over 2? Where does it land? That gets you the right quadrant. And now we know that over 6 is always shallow, over 4 is always the middle, over 6 is always, over 3 is always the steep one. Now, we still got more blanks to go here. And those are going to be the coordinates, or the cosine and sine of all those angles. But there's a fun way to do that, and we're going to, you guys at home, you're going to miss out on the cutting and pasting fun here that we're about to do. But we'll come back and you can label it when we get back. On the unit circle, remember that this coordinate at pi over 6 is x comma y. Well, let's just worry about that for now. So take your 30-degree triangle, and if we slide it in there, it should fit just perfectly. Pretty close to perfectly anyway. We know it's called the unit circle because the radius is 1. Our hypotenuse landed on the radius. Obviously, that's not by accident. The first coordinate is the x coordinate. So based on the lengths of those triangles, what's the x-coordinate of that point? Which one of those sides corresponds with the x-coordinate? Root 3 over 2 or 1/2? Yeah, root 3 over 2 is the x-coordinate, right? Because that's the left and right coordinate. The up and down coordinate is 1/2. So that means the y-coordinate is 1/2. Now there's a couple ways we can go with this. I think let's keep rolling with this one. Let's flip it over to the other side. Now I had to flip my triangle over, so now my picture is upside down, or I'm only looking at the back of it, but I can still remember what the side links were, so you could relabel them if you want to. Again, radius is 1, matches up. X-coordinate, what about the x-coordinate for this one? It's negative, because we went backwards. Negative root 3 over 2. What about the y-coordinate? 1/2, positive 1/2, because it's up. All right, let's flip it into the third quadrant. And again, put the 30 at the origin. Okay, things are upside down now, but that's okay. We can make sense of where we're at here. So how about the x-coordinate at 210 or 7 pi over 6? What would the x-coordinate be? Upside down root 3 over 2. No. Negative. Not negative because it's upside down, but negative because it's backwards. Negative root 3 over 2. And the y-coordinate? Negative 1/2. And then we'll flip that around somehow and get it into the fourth quadrant. Back to the other side, but land your hypotenuse on the radius. And same thing, our x-coordinate is root 3 over 2, positive or negative? Positive, because we're moving to the right. How about the y-coordinate? It's negative 1/2. All right, so set your 30-degree triangle aside. And let's look at all the over 6's. What do you look at the x values for the over 6's? What do you see? The x values for the over 6's that we just did. They're all the same. I mean, they got the plus and minus thing going on, but they're all root 3 over 2. The plus and minus, though, is easy because that's just if you're left or right. So anything x-coordinate for over 6 is always root 3 over 2. So now we start getting into this. Well, how much of this do I need to memorize? Well, you're going to need to memorize this first quadrant. But once you know the first quadrant, it's easy to get the other 4 because they're all the same, or the other 3, I guess. They're all the same. Same with the y-coordinate. It's always 1/2. It's just a matter if it's a positive 1/2 or a negative 1/2. If it's going up or if it's going down. All right, let's do the 45. So grab your 45 triangle. You know what? Let's do the 60 one. Sorry. Because we're going to get the same values. So let's use the 60 triangle because it has the same numbers. They're just in kind of different places. But that makes sense. Both of those are 30, 60, 90 triangles. It's kind of just which one is at the origin, the 60 or the 30. So if I slot that 60-degree triangle in there, what's my x-coordinate going to be? 1/2. And my y-coordinate is root 3 over 2. And that's backwards from the 30. But that makes sense. It was the same triangle, just kind of backwards. We're using the 60 rather than the 30. All right, and we'll put the 60 in the next quadrant, although you got to flip it over, so maybe you got to relabel some things. Again, put the 1 on the hypotenuse, or the 1 on the radius. And again, the x-coordinate now is, well, left, right one, so that's 1/2, although it went to the left, so it's negative 1/2. The y-coordinate is root 3 over 2, positive, because it's going up. All right, let's live life on the edge a little bit here. How about into the third quadrant without using the triangle, but using the other over 3 angles? What do you think the x-coordinate at 4 pi over 3 is going to be? Negative 1/2, because it's the same x-coordinate as all the other over 3's. And root 3 over 2 is its y-coordinate, but it's negative because it's down. And then into the fourth quadrant, again, put the triangle on there if you want to, but you can also just look around at all the other over 3 angles and see that all of the x's are 1/2. Is it a positive 1/2 or negative 1/2 in the fourth quadrant? Positive. The y's, I look around, all of the y's are root 3 over 2. Is it positive or negative? Negative, because we went down. So again, thinking about memorizing, looking at the first quadrant. Usually we say you have to memorize the first quadrant. It's really kind of less than that, though, because as long as you memorize the 30 correctly, then the 60 is just the reverse. So it's not like 4 separate pieces of information you got to know. You got to know the first one, and then if you just remember that, well, 30 and 60 are backwards, so I'll switch the x and the y. And then you can symmetric your way all the way around with pluses and minuses. All right, let's put the 45, 45, 90 triangle in there. Maybe we should have started with this one because this is the best one. Because what happens if you get your x and your y confused on this one? It doesn't matter. They're both root 2 over 2. That makes sense. 45 is right in the middle. The x and the y are the same. So the x and the y are the same. You probably don't need the triangle anymore, but you can move the triangle into the second quadrant and realize, oh look, the x-coordinate is negative root 2 over 2, and the y-coordinate is root 2 over 2. And then third and fourth, the same thing. They're all root 2 over 2. It's just a matter of who's negative. Who's negative in the third quadrant? Both of them. Fourth quadrant, everybody's still root 2 over 2 at the over 4 marker. The x-coordinate is positive, the y-coordinate is negative. So we've got almost everything filled out. But again, you're not having to memorize the whole thing. If you know the first quadrant, you got it all. But even then, if you know pi over 6 and pi over 4, you've pretty much got it all. And pi over 4 is the easy one because they're the same. So there's not a whole lot of different values you have to know to complete the unit circle. In fact, there's really only 3. 1/2, root 3 over 2, and root 2 over 2. And root 2 over 2 is easy because that's the pi over 4s. The others are pretty easy to keep straight because you can just look and tell if it's whichever side is the long side is root 3 over 2. So the x side is long, it's root 3 over 2. If the y side is the long side, so if it's steeper, then the y is root 3 over 2. If it's shallow, then the x is root 3 over 2. Same with the 1/2. 1/2 is always the short side. So if you got a short side, it's 1/2. If you got a short side, it's 1/2. So yes, you have to know the whole unit circle, but surely you can figure out some ways and see some symmetries that you don't have to memorize every single blank. You figure it out. And when the time comes and I ask you, what's that blank right there? Most of you won't know exactly right away. You'll have to do some thinking and think, okay, that's over 6. Or I'll just think, oh, that's the shallow side, and that's the y, so it's 1/2. There's only a few values you have to know. All right, there's a few blanks left, though. And these are the easiest blanks, but people forget them, I think, because we don't test them well enough or test them often enough. What did we say the radius of this circle was? 1. So from right here at 0 degrees, so that length is 1. I don't have a triangle for this because it'd be a flat line. What are the coordinates of that point if I'm 1 away from the origin to the right? 1, 0. So it's just ordered pairs. So at the top here, at 90 degrees, what are the coordinates? 0, 1. Sometimes people get their x and their y's backwards, so that's not a unit circle issue, though. Over here at 180, -1, 0. Kind of missing the left parentheses there. -1, 0. And down there at 270, let's see, 0, -1. Let's see, what else do we need to say about this? Let me just pause and reiterate that we looked at those as the coordinates, right? That was the x, y. But the thing about the unit circle is that those coordinates are also the sine and cosine of, or the cosine and sine, I guess if we want to get in the right order, the cosine and sine of whatever angle that is. So if someone asks for the cosine of 60 degrees, can you tell by looking at your unit circle what the cosine of 60 degrees is? What is it? 1/2. We'd go to 60 degrees. Cosine would be the first one. So 1/2. What about, so don't call it out loud, see if you can locate the sine of 5 pi over 4. Sine of 5 pi over 4. So we go to 5 pi over 4. Pick out the correct coordinate. And what's the sine of 5 pi over 4? Well, shoot, I picked one where if you got the wrong coordinate, you still get it right. Am I looking at the x coordinate or the y coordinate? The y coordinate. They happen to both be the same, but yeah, the sine is the y coordinate. So that means the sine of 5 pi over 4 is -√2 over 2. That's how we'll use, well, not exactly how we'll use the unit circle, because we'll get to where we only need the first quadrant. Let's do one more of those. See if you can figure out what the cosine of 330 degrees is. Cosine of 330 degrees. Yeah, once you get the hang of it, it's like, oh, well, I look at 330 degrees. I pick out the x coordinate. It's √3 over 2. Like, why is this difficult? Well, it's not. If you're sitting here staring at the unit circle, it's not hard for sines and cosines. Now, we'll also get a little bit tricky and ask you to do tangent. So let's write what tangent is. Tangent of theta. What do you remember about tangent? Tell me anything you know about tangent. Opposite over adjacent. That's what most people remember first about tangent because they're thinking SOHCAHTOA. But we know that opposite goes with y and adjacent goes with x. So the tangent is y over x. So finding the tangent's a little bit harder because you've got to use both coordinates and do one over the other. It's not that difficult, but it's a little bit difficult than just picking off the numbers. Right, let's say one more thing, and then we'll do some of the worksheet together. This positive, negative stuff, that's talking about sine, cosine, and tangent. We've talked about this a little bit already. In the first quadrant, everybody's positive. Sine, cosine, tangent, nobody's negative. In the second quadrant, who's positive? Sine, because sine goes with y. All my y coordinates are positive. So sine is positive, cosine's negative. And what does that mean for tangent? It's negative because it's the ratio of sine over cosine. Oops, I should have put that at the top as well. So it's y over x, but that's the same as sine over cosine. So there's two ways to think about it. And tangent is negative in the second quadrant. Third quadrant. Is sine positive or negative? Is cosine positive or negative? So therefore tangent is positive, right? Because it's the ratio, two negatives make a positive. We've kind of done this part already.
Is this like the little chart thing where it's like all students?
Yeah. I'm going to write that down. In the fourth quadrant, my x is positive, so that means cosine is positive. Y is negative, so that means sine is negative. And then a ratio would also be negative. But most of the time we don't think through all that. I mean, there's nothing wrong with thinking through it like that. But we use all students take calculus more often than not to figure out who's positive. All sine, tangent, cosine. That's kind of the shortcut to figuring out who's positive. Let's see. Let's just do a couple of makeup problems down here. We got room. So I want you to find the sine of 4 pi over 3. And then the cosine of pi tangent of pi over 3, and then the tangent of 90 degrees. So try those four. First two are super easy. Third one, you'll have to do a division problem, or third and fourth one, you'll have to do y over x. So give those a try, see what happens, and then we'll compare notes in just a second. All right, sine of 4 pi over 3, what's that equal to? Negative root 3 over 2, right? I go to 4 pi over 3, I pick off the y coordinate, negative root 3 over 2. Easy peasy. How about the cosine of pi? Negative 1. I go to pi, I look at the x coordinate, it's negative 1. Tangent of pi over 3, that's going to be y over x at pi over 3. So it's going to take a little bit of work here. Pi over 3, the y coordinate is root 3 over 2. And the x coordinate is 1/2. And some people can know how to reduce fractions from there. Like both 2's are in the denominator, so they'll cancel. It's a good rule to know, because look at all of your denominators all the way around the circle. If there's a denominator for sine or cosine, it's 2. So if you cancel the 2's, then you get root 3 over 1, and it's just square root of 3. Some people will memorize the tangents, others will just do y over x every time. It doesn't matter to me. I think y over x is probably, it doesn't take long, so I think I would just do that. Tangent of 90, y over x. The y coordinate is 1, the x coordinate is 0. And 1 divided by 0 is not 0. It's okay. It's why we're doing this one. Undefined. You can't divide by 0. So undefined is a potential answer choice on today's assignment. Only for tangent, but it's a potential answer choice because you can't divide by 0. So you needed to see that before you hit it in the worksheet and then didn't know what to do with it. All right, so the worksheet you've got, the first page is a blank unit circle. I wouldn't fill it out right now because, what's the point? We just did it. That's just, you don't have to ever fill it out, really. But if you want to test yourself early next week sometime, then you've got a blank one. I've also put this in Schoology, so if you want to print 500 blank ones and fill them all out, knock yourself out. That'd be a little bit overkill, but it's there if you want it. Today's assignment is worksheet 1, so let's flip it over and see if there's anything that looks out of whack there that we haven't quite covered. I see a couple things that we haven't quite done.
I don't have a packet.
Uh-oh. If you wanted 2 of them. Do you see anything on there that we haven't done? I would say the answer is yes. You should see some things there we haven't done. 21. Sine of negative 315. Yeah, I don't know where negative 315 is. So, what is the angle that lands at the same place as negative 315, though? Coterminal. How do I get a coterminal angle at 360? So that would be 45. So the sine of negative 315 is the same thing as the sine of 45 because coterminal angles. So that's the sort of last piece of the puzzle, a piece that we already know, but coterminal angles. If you get an angle you don't like or it's not on the unit circle, again, you can add or subtract 360 or 2 pi, depending on which mode you're in, however many times you like to sort of make it work. Now, some people are not going to do that. For easier angles, there's a way around that, like cosine of negative pi over 4. So the coterminal way is, well, let's add 8 pi over 4. That gets me to 7 pi over 4. And here's the other reason I wanted you to have a separate page. Otherwise, you're flipping back and forth, and that's just kind of annoying. So off to the side, you've got this page. You go to 7 pi over 4. The cosine is the x-coordinate, root 2 over 2. But some people, they're like, negative pi over 4. I know how to get negative pi over 4. That's just backwards. Pi over 4. That's going to land me right there. The x-coordinate is root 2 over 2. So if you're comfortable going backwards, go backwards. If it's backwards a lot, like maybe that minus 315, you're like, I don't know that I want to do that. Maybe I'm not comfortable with that. I'll do coterminal. But if it's something simple, let's see if there's another one. Number 7, cosine negative pi over 6. Well, pi over 6 is only 30 degrees, so if I back up 30 degrees, I don't have to worry about the coterminal thing. So your choice, you can treat them all with the coterminal thing, or you can kind of figure them out. The other thing with coterminal is that if you have one that's too big, like sine of 405, like 405 degrees, that's not on my unit circle. Well, no, it's not, but I can find a coterminal angle that is. And I can find the sine of 45 and see that that's root 2 over 2. All right, so today's assignment is that worksheet, and for today, we're going to get to the point where you don't need the unit circle. But today, we're still familiarizing ourselves with it. So today, I don't mind if you fill out this worksheet while you're staring at the unit circle, just going back and forth, because the point is to just kind of get familiar with the unit circle. Speaking of being familiar with the unit circle, I always say this, people always laugh, but you need to, at some point, take your unit circle on a date to Sonic or somewhere, okay? You're like, what are you talking about? And I just mean you need to spend a few minutes looking at things and seeing all the different symmetries. We talked about some of them, but the more you look at it, the more things that are there. And you'll be like, wait a minute, I didn't realize that this and this had the same whatever. They're not millions, but there's lots and lots of symmetry there. And if you'll spend 5 minutes just kind of looking, especially at your highlighted things, you'll start to realize some things. And so my encouragement to you is, at some point, 5 minutes, just kind of look at the different values and where they are and see what you notice, because there's lots of symmetries there. Especially in locating the angles. That's an easy one to do, like what quadrant we're in. You look in quadrant 2, all of those are almost pi, right? 2 over 3 is almost pi. 3 over 4 is almost pi. 5 over 6 is almost pi. You go in the third quadrant, they're all like one notch past pi. 7 over 6 is 1/6 past pi. 5 over 4, 1/4 past pi. 4 over 3, 1/3 past pi. So there's a lot of little goofy things like that going on in the unit circle. So assignment today, finish the worksheet staring at the unit circle. It's fine. We're going to get away from that, but today it's okay. And at some point, hang out with your unit circle a little bit and get to know him a little better. He will communicate with you if you spend time with him.
On the test, we're going to fill out the unit circle, right?
So on the test, what I'm going to have you do, or suggest you do, is not fill out a unit circle, but you're going to make freehand on your own a first quadrant. 45, 30, 60. This is what most people do, and by then they'll know, okay, the x-coordinate, that's the long side, so I know that's root 3 over 2. Means the other's 1/2. 45, I already know, that's the easy one, root 2 over 2 and root 2 over 2. At 60, that's a steep angle, so the y-coordinate is the tall one, the x-coordinate is the short one. So the short one is 1/2, and the tall one's root 3 over 2. And from there, I can figure out anything I need. So on test day, that's what I will expect you to do. And then, well, we'll talk about how to solve the rest of them with just the first quadrant later. So today's assignment, finish that first worksheet. Don't go on to the others, because I don't want you doing the other worksheets by just staring at the unit circle, because we need to get away from that.